Hey everybody, how's it going? So today we have another A1466. This MacBook is not powering on. Let's see if we can figure out what's wrong with it and get it working again, and perhaps get this guy a sticker with this same bicycle but with a bafang on it. So let's get to work. So first thing we're going to do here, open this thing up, put it on the table, figure out what's wrong with it. Let's open it up. Alright, let's see what's wrong with this MacBook. So first thing we're going to do, as we always do, is unplug the charger. Unplug the battery, because the battery is going to give us a strange amperage reading. Plug this in. Are we taking anything? Alright, looks like we're grabbing 6 milliamps and nothing is coming through here. So let's get the board out of the machine and figure out what is going on here. Yeah, it looks like it's not even activating the charger at all. It's almost, is this plugged in? Okay, it is plugged in. That's really strange. There's some dirt over there that I'm missing. Nah, alright, let's take it out. Beautiful. It's taking nothing. Now remember, in order to get a green light in the charger, the one-wire circuit has to be working. I would highly suggest that you check out my videos on the one-wire circuit if you're interested in it. On boards.rossumgroup.com, you can actually see that there's all organized into a playlist called No Green Light, where I talk about the one-wire circuit and why it's required to get the green light in the charger. Now, the chip that's going to be speaking with the charger is this chip, the SMC, and there's 2 chips on the DC in board right here that are going to facilitate the speaking going on. These are going to protect that data line in case somebody plugs this in improperly. So let's say that you're plugging it in sideways. Instead of the data line pin speaking to the SMC, you may get the 18 volts touching it. And this chip over here is like a protector. It's kind of like the SMC's bodyguard. So that's all going to be powered by 3.42 volts, and we have to see if we have that on this board, which means the software has to be in voltage mode. Unfortunately, the Paul Daniels software is now in resistance mode while my meter is in voltage mode. We just smack the Paul Daniels software right there, and it works again. Now, it looks like we're getting 0.01 volts on PP3V42_G3hot. So let's open up the schematic as well as the board view for 820-3437 board, and we are going to take a look at the PP3V42_G3hot circuit and see why it is we're not getting PP3V42_G3hot. Now, first thing that we need, obviously, is going to be voltage coming into the chip. So if we have a charger plugged in, if we've got a charger plugged in, that means that we're going to see that voltage on R7005, and also, ideally, if there's no short circuit over on the input stage from these caps to ground, right after the diode. So let's go after that. We're going to check D7005 around there and see if we have input voltage. Alright, 18 volts here. 18 volts on input with 17.7. There's a little voltage drop from the diode, no big deal. This circuit doesn't use much amperage, so even if we do a voltage drop, no big deal. 3.46 volts. So we have 3.46 volts, but no green light in the charger. And PP-G3hot is 8.19 volts. Now, let's talk about what this means. So, there are 2 SMC functions that are not working right now. The first SMC function is we don't have a green light in the charger. The green light in the charger is created when the system management controller is able to speak to the charger. The second thing that we don't have is PP-G3hot being the right voltage. Now, in order to explain this properly, I'm actually going to have to show you how the circuit works on an older board, because I don't have a schematic for the DC in board. So I'm going to open up a schematic for some other board that will allow me to demonstrate what's going on here that uses a very similar circuit. So if you take a look over here, you'll see that we have 18 volts coming in. That's from the charge port. This over here, J7000, is the charge port. The second is we're going to have what's called adapter sense, and the third is ground. Now, adapter sense is going to be a data line. And this chip over here is what is the bouncer. Remember when I explained this, like, think of it like your private security? So U7000 is like your private security guard that doesn't allow this data line to speak to the SMC unless it sees that everything is all right. And over here you have a line called sys1 wire. That's the line that's going to be going straight to the SMC. So if I click on that right over here, you'll see on U7000, that chip, that data line goes straight to the SMC, sys1 wire. Now, this circuit over here, the reason I call this little chip U7000 like a bodyguard is if you send adapter sent a 3-volt data line, it lets it through. If you send 18 volts because you're drunk and you're plugging your charger in wrong, then it's going to destroy the SMC. But we don't want to destroy the SMC, so U7000 is a bodyguard. If you put 18 volts of DC there, it says, screw you, I'm not sending you to sys1 wire. This circuit needs PP3V4 G3 hot to work. This chip is going to power that one, and this chip gets powered by PP3V4 too. This circuit requires the SMC. This is one SMC function, being able to communicate with the charger in order to get a green light. You need that communication with the charger in order to get a green light. Now, the SMC also has another function. Remember when I just said that PP bus G3 hot is the wrong voltage? It's measuring 8.19 volts? What do I mean by that? That's a great question. So let's go over the circuit that creates PP bus G3 hot over here. Now, this circuit is going to create PP bus G3 hot. What you see on the screen right here. So this is going to take the voltage from the charger, and it's going to turn it into PP bus G3 hot. See? Now, PP bus G3 hot is usually 8.5 volts, but now it's 8.1 volts. Why is that? Well, it's that this chip is actually going to speak to the SMC on this bidirectional data line. See SM bus charger SDA and SM bus charger SCL? Let's see where those go in the schematic in the board view. If we click on this, you'll see that Paul's software doesn't show it. But luckily, I remember which pins it's on so that Paul's software can't sabotage me. Haha, Paul. Now you'll see that this speaks directly to the system management controller. So the system management controller is going to speak to the ISL 6259 and say, listen, 8.1 volts ain't enough. I want 8.5 volts. That's not good enough. So what we have here is we have two SMC functions that are not performing like they're supposed to. And this helps me narrow down the cause of the issue. There's two things that are broken. When I have more than one thing that's not working, I don't want to try to fix each individual problem. What I want to do is say, what do those two things have in common? And here, what those two things have in common, besides Paul Daniels' software, is that they both are related to the system management controller, this chip right over here. Ooh, well, what do you know? Corrosion. Now, the green corrosion on these capacitors is honestly probably not the main cause of the problem. Indeed, Voidhan, indeed. This is not going to be the cause of my problem. The cause of the problem is most likely that some of that green stuff got under the chip itself, and that's going to be what we need to focus on today. So, sometimes this stuff comes off real easy immediately, and sometimes it's a royal hassle. And today's material appears to be a royal hassle. I like that you explain this over and over and keep it up. All the best from Germany. Thank you, Anafan. Alright, now the last thing I want to do, so I don't make a total jackass of myself, is make sure that SMC Reset L is present. SMC Reset L is a signal that's going to turn on the SMC. So keeping in the spirit of explaining things from scratch, there's a signal called SMC _ Reset _ L. And what that does is it tells the SMC to turn on. So anytime you see _L in a signal name, that means the signal is present when it's low. And what reset is going to mean is stop working altogether. Before I do that, I think I'm just going to give this a minor reflow. Just a little bit of a reflow. Nothing too big. Now, to help fund the new store, we sell flux. So I think it's important that I be honest about how much flux you need as an influencer in order to reflow chips, just to make sure that we hit our sales target. I value honesty and transparency, so I would never use more flux than needed in the attempt to influence sales. That is the amount of flux that you need. If you use any less flux than this, the board won't even work when you're done. See? Paul, say nothing if you agree with me. Paul S., say nothing if you agree with me. See, Paul agrees with me. Alright, so we're going to give this a nice reflow. I agree with you, Vico-san. Justin, I am thinking of scheduling one for later today. I'm gonna have to. We try avoid them. Alright, let's see if iron gets hot. Is iron hot? Iron is not G3 hot. Oh, yes. Is my tip dead? My tip is dead. Oh, my iron is dead. Let's see.
I don't know if you might like that.
Yeah, I'm gonna have to fix my tip at component level later. Alright, this is not exactly the knife tip that I enjoy. But, well, we're gonna make do with it because I don't even think this is a knife tip. I think this is a tweezer. Is this a hot tweezer tip? You're using a hot tweezer tip, aren't you? You savage. David is a savage. David was raised by wild wolves, where they use HAKKO hot tweezer tips in the micro pencil. Just going to reattach the stuff that looks nasty. Okay. Next up, we're going to file off these caps over here. And I don't believe any of these are shorted or broken. Okay. Now we're going to see if the SMC is able to communicate properly with everything. I'm going to take my charger, plug it in, and we're probably going to get a green light and then 500 milliamp draw and fan spin. That's how we roll. Okay, we get a green light, 500 milliamps. See 500 milliamps right here. And fan spin. This is the 820-3437, so it's going to turn on, turn off, turn on, turn off, turn on, turn off, turn on. And you'll also be able to see that our PP Brush G3 Hot, which was 8.1 volts before, is a happy 8.5 volts now. So that's about that. The SMC was keeping not only PP Brush G3 Hot from becoming the proper voltage, but it was also keeping the green light from turning on the charger. The SMC was not turning on due to minor corrosion. Now, even though there was, I can't really tell if there's corrosion under it, and it didn't look like it was coming from under it. The corrosion on those small caps by the SMC tells me that something likely leaked under the SMC, and the best way to go about that, in my opinion, is to use some good flux, give it a reflow. You know, you don't have to go crazy with it. Don't kill the chip, especially in the beginning. Using less heat is better than using more, especially if you're just looking to get rid of corrosion, not actually solder. Again, there's a difference between trying to get rid of corrosion and actually resoldering. And it works. We're going to toss this in the ultrasonic cleaner to get rid of any sort of corrosion under there. Now, many of you may wonder, why do I do that before putting it through the ultrasonic? And that's a great question. So let's say there's a hardened solder ball, right? Now, if it got corroded, it's going to be a bunch of little pieces of dust. It's going to be like, sand. I don't want to wash the sand away. I want to turn that sand or that back into a rock. I don't even know if sand is what they make rocks out of, so this is probably a really dumb analogy. Hopefully you get the idea. But I don't want to have all those that solder ball that turned into a bunch of corroded little junk. I don't want that to flow away and wind up in the bottom of my ultrasonic cleaner. I want to take those little bits of sand and turn it into a rock again so that it is nice and hard and attaching the SMC to the board. And then once that's reconstructed properly, then we can deal with cleaning all the corrosion off, not the other way around. What I did there is I probably saved myself the amount of time that it would take me to have to take that chip off and reball it when it probably doesn't need a reball. So that's it for today, and as always, I hope you learned something. Thank you so much for watching. Thank you so much for learning, viewing, sharing, and hopefully you took away something from this that you can use to fix a machine that Apple said could not be fixed. And I'll see you in the next one.
Lost in this moment is where I want to stay. This can't